All right, I want to go through a few of the problems that you were going to try there on the worksheet. The first one is number 6, the one where they ask you to solve for x when we have 3 to the 1 minus 2x power, and it was equal to 4 to the x power. All right, so a few things going on here, but both cases, or both sides, I should say, we had an x that we wanted to solve for. And they're both in the exponent. So we know to start with, I want to take the log of both sides because that'll allow me to take the exponent down. So what I'm going to do is I'm actually going to kind of combine steps. I'm going to bring down the exponent, keeping in mind I could do that if I took the log of both sides. So that's my first step. Now, from there, I kind of have some options. But what I like to do is I like to stay fairly consistent. So usually at this step, we're going to now do some division. So I'm going to go ahead and divide by the log of 3 on both sides. Because that'll allow me to cancel this log of 3 here. So now we have 1 minus 2x. And I have x times this value that I get once I type that into the calculator. Now I'm going to hold off on typing it in because I want to try to keep as much accuracy as I can. All right, so let's think about what we have. We got 1 minus 2x on the left side. On the right side, I have x times log of 4 divided by log of 3, or another way to think about this is log of 4 divided by log of 3x. Well, anytime we solve an equation, our goal is try to get all the x's on one side and everything else on the other. So I'm going to add 2x to the other side. Well, over here, I'd have whatever the log of 4 divided by log of 3 is, times x. Plus, now I have an additional 2x that I'm putting over there. All right, well, now I can start plugging things in. So this left side, or the right side, I should say, we're going to combine like terms. So this is where I could punch in the log of 4 divided by the log of 3. And I'm going to take that answer plus 2, because I had an additional 2x. So this is roughly 3.262x. I'm keeping that value on my calculator, though, because I want to be accurate. So now I'm going to do 1 divided by that value. And my x value should be 0.3066 if I round to 4 places. So backing up, again, we did the log of both sides, which allowed me to bring down the exponent. I went ahead and divided by the log of 3, because that's really just a value I can work with. Got all the x's on the same side, and eventually then solved for x. All right, number 8. Now, number 8 was actually kind of nice because we didn't have x's on both sides. So I'm going to start out by trying to get that exponential part by itself. So I'm going to divide both sides by 3/10. Now I have this, 4 to the 0.2x is equal to whatever 0.2 divided by 0.3 is. All right, I need to get that x out of the exponent, so now I do the log of both sides and bring it down. So I have 0.2x times the log of 4. That's equal to the log of 0.2 over 0.3. Now, remember our goal. Our goal is to solve for x. Well, I could actually do this in one step now because all that is multiplication there on the left side. So I know to get rid of multiplication, I can divide by 0.2 times the log of 4. So I do that over here, 0.2 times the log of 4. Now it becomes a calculator exercise. So we're going to do log of 0.2 divided by 0.3 is So that gives me approximately negative 0.1761. Again, you want to keep that in the calculator. Divided by, now I have to put this in parentheses, but 0.2 log 4. And so when I put that together, my x value comes out to be negative 1.4624. Then you got to number 9. Now, on number 9, there's no reason that we can't use logs. It's fine if you decide to use logs here. But don't forget about some of our other methods. One of the first things we talked about was if I could ever get the bases to be the same, then I could solve for my exponent that I have. Well, in this case, I've got an 8 for a base and 4 for a base. So I can make 8 really 2 to the 3rd power. I can make 4 2 to the 2nd power. Well, this makes my life easier because now the base is 2 on both sides. So if I just focus on the exponents, I should be able to solve for x. So I've got 3 times 6 plus 3x, or in other words, I've got 18 plus 9x. And it should be equal to this exponent, which is 2. So this one, when I subtract 18 and I divide by 9, I get negative 16 ninths. Or if we divide it out, negative 1.7 repeat. So even though logs are a good option, they're not the only option we have. And sometimes it may be just as easy to, if we can do it at least, try to get the bases the same. All right, so wanted to show you those 3 problems just to make sure we're on the right track. So continue to work on the ones that we asked you to try. And then we'll start looking at some of the holes that we skipped over there as we attack things in class next week.